Hi, I'm Don Dawson. Today we're going to talk about a hot topic. Since the dawn of man, fire has been a powerful tool, allowing us to cook food, keep warm, and illuminate our surroundings. But throughout our history, fire has also been a devastating destroyer. Even with modern firefighting techniques, accidental fires are still a leading cause of destruction, disability, and death. And today's fires are more dangerous than ever, because plastics, flammable chemicals, and other man-made substances can cause fires to spread quickly, as well as release toxic fumes. The best way to fight a fire is to prevent it. But first you must know what causes things to burn. All fires involve three elements: heat, fuel, and oxygen. Removing any of these will stop a fire. Let's look at each of them in greater detail. Fires start with heat, which serves as a source of ignition. Heat can be generated by many things, including open flames, static electricity, cutting and welding operations, faulty electrical circuits, unshielded hot surfaces, friction, and chemical reactions. Once a fire is burning, it produces more heat and grows even larger. As long as there is enough fuel and oxygen, a fire will continue to spread. Fuel can include combustible solids like paper, wood, and some metals, flammable liquids, and ignitable gases. The vapors coming off a flammable or combustible material mixed with oxygen in the air produce flames. Some materials are always giving off flammable vapors, while others have to be heated. For example, you have to apply heat to get a log to burn. The heat from the flames causes the wood to decompose, creating ash and flammable vapors. These vapors mix with oxygen in the air to produce more flames. Since all fires are composed of heat, fuel, and oxygen, the chain reaction will continue until the oxygen runs out, the heat is removed, or the fuel is used up. The temperature at which a material gives off flammable vapors is known as its flash point. Some materials have extremely high flash points and require a tremendous amount of heat to burn. Other substances have low flash points, which makes them easy to ignite. A good example of a substance with a low flash point is gasoline, which can be ignited at -45 degrees Fahrenheit, -42.8 degrees Celsius, or above. Gasoline and other substances that have flash points below 100 degrees Fahrenheit, 37.8 degrees Celsius, are considered flammable. These materials are especially dangerous because they are almost always giving off vapors that can burn. Materials that have flash points between 100 and 200 degrees Fahrenheit, 37.8 and 93.3 degrees Celsius are considered to be combustible. Because combustibles, such as kerosene, have to be heated up before they produce ignitable vapors, they are easier to control and safer than flammables. In addition to heat and fuel, a fire needs plenty of oxygen. The more oxygen there is, the greater the amount of fuel that will burn. This is why fanning a fire causes it to get hotter. As a fire grows, it begins to draw in oxygen from the surrounding area, causing even more fuel to burn. As a result, a fire can quickly grow out of control, engulfing everything in its path. To extinguish a fire, this pattern must be broken. Fires are usually put out by applying substances that either remove the heat or the oxygen. What fuels a fire determines what kind of extinguishing agents can be used. This is critical because applying the wrong material will make things worse. Water will extinguish smoldering paper and wood, but can cause burning liquids to spread. Water also conducts electricity, so it cannot be used on electrical fires or where it could come into contact with live wires or electrical equipment. To identify the different types of burning materials and indicate what substances can be used to extinguish them, fires are separated into 4 classes: Class A, B, C, and D. Class A fires involve everyday combustibles, such as paper and wood. These are often put out with water, which cools the burning materials. Class B fires are fueled by flammable gases and liquids, such as oil and propane. These materials can be extinguished by applying chemical foams that blanket the area and cut off the fire's oxygen supply. Class C fires are electrical. These are also fought by smothering the fire. But to prevent electrocution, Class C extinguishing agents are non-conductive. Class D fires are fueled by combustible metals such as potassium, sodium, and magnesium. These fires are fought by covering them with dry sand or specially formulated chemical powders. This cuts off the oxygen supply and eventually smothers the fire. Class D fires are extremely dangerous, but not very common. If you have not been specifically trained to extinguish Class D fires, don't attempt to put one out. To slow the growth of a fire, the first line of defense is usually an automated fire suppression system. Most facilities use sprinkler systems that quench Class A fires with a deluge of water. Contrary to popular belief, sprinklers are not activated when a fire alarm goes off. It's the heat from a fire that releases the valve on most sprinkler heads. In areas where flammable liquids and gases are stored, automatic fire suppression equipment will usually apply Class B foam or dry chemicals to smother fires. Class C materials are used where high voltage electrical hazards exist. Most automated fire suppression systems are not designed to put fires out, but they do beat down the flames and help keep them from spreading. This allows people to evacuate and gives fire departments a fighting chance to save the building. People who have been trained to fight fires are the second line of defense at most facilities. Typically, these workers are only authorized to extinguish small fires, but some facilities have in-house fire brigades capable of handling much larger blazes. Of course, using a fire extinguisher is often the best way to put out a small blaze. There are many types of extinguishers. They discharge a range of materials, from water to carbon dioxide to dry chemicals. Before using an extinguisher, make sure that it is compatible with the class of fire you are fighting. If the extinguisher's label doesn't indicate that it is rated for that class of fire, don't use it. You will often see fire extinguishers that are marked A, B, and C on their label. This means that they can be used to extinguish all of these types of fires. To put a fire out with an extinguisher, use the pass method. Pull the pin. Aim the nozzle. Squeeze the trigger. Sweep from side to side. Once the extinguisher is empty, place it on its side in an out-of-the-way area so no one will try to use it again. Most extinguishers empty in less than 15 seconds. If you can't put a fire out in that length of time, you should evacuate the area immediately. Now that you know why fires start, what causes them to spread, and how to extinguish them, you should be able to recognize potential fire hazards. Your company's fire prevention plan will help you by listing sources of ignition and major fire hazards in your facility. An important part of the plan deals with how to properly store and handle hazardous materials. Many industrial fires occur because flammable materials are stored improperly or used incorrectly. Make sure that flammable substances are well away from sources of ignition and store them in containers approved for industrial use. Gasoline and other flammable liquids should be stored in safety cans that are outfitted with flash arresters. These wire mesh devices prevent flames and sparks from entering the mouth of a container and igniting the substances inside. Special care should be taken with spontaneously combustible, shock-sensitive, and chemically reactive substances because these materials can be highly unstable. Spontaneously combustible materials, such as varnishes that contain linseed oil, produce heat as they dry. Since rags soaked with these materials can burst into flames, they must be disposed of in sealed metal containers designed to handle ignitable waste. Substances like nitroglycerin are shock sensitive. These types of materials can detonate and start a fire when they are shaken or dropped. Shock-sensitive materials require special handling procedures, such as being stored at very low temperatures. Some substances can start a fire by reacting with other materials. Water-reactive substances, like calcium carbonate, produce ignitable vapors when they get wet. So you need to keep these types of materials in airtight containers and store them in dry locations. While open flames are obvious fire hazards, some ignition sources are more difficult to spot unless you know what to look for. For instance, static electricity can build up in containers that are designed to hold flammable materials. Plastic containers that have been transported in trucks with plastic bed liners are especially prone to static charges. The static is generated by friction as a can rubs against the liner. If a statically charged can is left on the truck, a spark can discharge at the mouth of the can when it is filled, igniting flammable vapors. To prevent this, containers should always be grounded before they are filled. This allows the static electricity to harmlessly discharge. With small containers, you can just place them directly on the ground. Large containers should have grounding wires connected to them before they are filled. Sparks from tools and equipment can ignite flammable materials as well. Hand tools like shovels can create dangerous sparks when they scrape against hard surfaces. You can protect yourself in these situations by using spark-proof tools made out of materials like polypropylene that are treated with anti-static agents. Forklifts and powered equipment that are used around flammable materials must be equipped with safety features that prevent their mechanical parts from creating sparks. Small electronic devices, such as cell phones, can create sparks that could ignite flammable vapors as well. You should never use these devices in areas where vehicles are fueled or flammable substances are handled. To learn what equipment is safe to use in flammable environments, check their nameplates, consult user's manuals, and talk to your supervisor. Fires can also be started by welding and cutting operations, electrical equipment, and careless smoking. Let's take a look at how being aware of your surroundings helps prevent these fires from starting. Stray sparks from welding and cutting operations cause a number of industrial fires. The best way to prevent these fires is to follow safe work practices. Move ignitable materials away from the area. Place fireproof blankets over materials that can't be repositioned, and use guards to prevent sparks and hot metal fragments from scattering. Even with these precautions, a stray spark or piece of hot metal can escape, so posting a fire watch can be critical. Since hot embers can smolder for some time before they actually ignite a fire, Employees on fire watch must look for signs of fire both while the work is being performed and for at least a half hour after the job is done. Other major causes of industrial fire are faulty electrical equipment and overheating. Overloaded circuits cause a lot of electrical fires. Overloads occur when equipment draws too much power. In time, this can cause wiring to heat up and burn. To avoid overloads, make sure that wiring is rated for the equipment you will be using. And don't plug too many devices into the same circuit. Fires can also start when wood shavings, grease, and other ignitable materials build up on areas of a machine that get hot. To avoid this, keep equipment clean, especially around electrical parts, such as motors or areas where friction can create a lot of heat. If you notice equipment overheating or see frayed or loose wiring, shut off the power and notify your supervisor. Paying attention to your surroundings while you work and being aware of potential hazards can prevent many on-the-job fires. But it's also important not to let your guard down when you go on break. When you're cooking, don't leave toaster ovens and other appliances unattended. If you smoke, be aware of your environment. Don't light up around ignitable materials. And be careful when you discard your cigarette butts. Make sure cigarettes are completely out before you toss them, and only dispose of butts in proper containers, such as specially designed receptacles or metal pails filled with sand. Regardless of how many precautions you take, a fire can still occur. This is when fire alarms and smoke detectors save lives. To be effective, fire alarms and smoke detectors should be strategically positioned throughout your workplace, including the basement and other storage areas. If you hear one go off, you should leave the area immediately. So that everyone in your facility knows what to do in the event of a fire, your company must have an emergency action plan. This plan will describe how to report fires, as well as the evacuation procedures for your facility. Each employee should know of at least 2 escape routes, so that if one path is blocked, they will have another way out. Always keep evacuation routes uncluttered and make sure all exit doors can be opened from the inside. Otherwise, you could find yourself trapped. Your facility's emergency action plan will also list a location for you to report to, as well as a way to make sure that all employees have been accounted for. Emergency personnel should be notified immediately if anyone is missing. When you are evacuating your work area, there are several basic guidelines to follow. Always remain calm. Walk, don't run, and never push past other people. Follow your predefined evacuation route, but be careful that you are not heading into danger. Never use an elevator to escape from a burning building. You could get trapped inside if the power were to fail. Use the stairs instead, but be cautious when you approach closed doors. Make certain that doors are cool to the touch before opening them. Check doors with the back of your hand. It's more sensitive to heat than your palms. Never open a door that is hot. It probably has flames behind it. If a door is cool, you can proceed on through, but be sure to close it behind you. If you have time, shut all windows too. This will limit the amount of available oxygen and help contain the fire. When a building is burning, smoke can quickly build up and make it impossible to see. So you need to know your evacuation route blindfolded. Since smoke rises, get close to the floor to avoid inhaling it. Cover your face with a wet cloth if possible, and take short breaths. Smoke can kill, especially if it contains toxic substances. So get to fresh air quickly, then seek medical attention. If your clothing catches fire, don't run around. This will only fan the flames. Instead, remember this simple phrase: stop, drop, and roll. Drop to the ground. Keep your legs and arms close to your body. Cover your face with your hands and roll back and forth until the flames are smothered. Remember, the best way to fight a fire is to prevent it in the first place. Let's review what you can do. Treat flammable and combustible materials with caution. Before filling a container, make sure that it is approved for the substance and properly grounded. Be careful when welding operations are taking place. Make sure that appropriate precautions have been taken. Look for possible sources of ignition and report dangerous situations. If you see an electrical hazard, switch off the power immediately, then notify your supervisor. Only smoke in designated areas. Make sure to thoroughly extinguish cigarettes and properly dispose of the butts. Know your evacuation routes. Keep them uncluttered and make certain that all exit doors can open. If you discover a fire, sound the alarm and get out. Most fires can be prevented, but there is always a chance that a fire will occur. By staying alert and following your company's fire prevention and emergency action plans, you can make sure that you don't get burned.